Good morning, students. Welcome to Computer Aided Design course code P20DE102, week 2, self-learning topic on applications and benefits of CAD. I am Rakesh, Assistant Professor in Department of Mechanical Engineering, Kids Warangal. Before going to enter this topic, let us see the lecture outcome for this topic. After completion of this lecture, student will be able to discuss various applications and benefits of computer-aided design. Uh, First, let us discussing about applications of CAD. Here, various applications are involved in computer-aided design. Let us see the first one. Assemblies are model merging. Second one is design applications. Third one, manufacturing applications. Fourth one, programming languages supported. CAD applications are basically divided into these four categories. First one is assemblies or model merging. Here, assemblies means generating assemblies and assembly drawings from individual parts is an essential process. You can take any modeling software, for example, like CATIA or Creo. We can generate assemblies and after completion of part modeling, we can do the assembly. For example, you can take universal coupling. Uh, Here it consists of 4 to 5 components like fork, pin and collar, center block. After completion of this part modeling, we can do assembly design. The two issues that means generating assemblies and assembly drawing. These two issues that are worth investigation are the assembly procedure itself and the cleanup of the resulting assembly. The second one is design application. There are design packages available to perform applications such as mass property calculations, tolerance analysis, finite element modeling and analysis, injection modeling analysis, and mechanism analysis and simulation. Here, what should be evaluated are the capabilities of these packages, their integration and interface with geometric databases, and the representation techniques they utilize. Without knowing any data, we cannot calculate mass property calculation, tolerance analysis, finite element modeling and analysis, etc. Some packages might require clumsy user input, while other might lack the proper way to display results. The third important application is manufacturing applications. The common packages available are tool path generation and verification, NC part programming, post processing, computer aided process planning, group technology, computer integrated manufacturing applications, and robot simulation. It is essential to ensure that the CAD and CAM applications that are provided by the system are truly integrated. The last one is programming languages supported. It is vital to look the various levels of programming languages a system supports. Attention should be paid to the syntax of graphics commands when they are used inside and outside the programming languages. If this syntax changes, significantly between the two cases. User confusion and panic should be expected. These are the few important applications in CAD. Let us discussing about benefits of CAD. This is the very important topic in CAD. Here number of benefits are available in CAD. Let us discussing each and everything related to CAD purpose. Let us see the few important benefits of CAD. Before going to discussing about CAD, let us see the uh, importance of CAD. There are many benefits of computer-aided design, only some of which can be easily measured. Some of the benefits are intangible, that means not measured, reflected in improved work quality, more pertinent and usable information, and improved control. Okay, all of which are difficult to quantify. The other benefits are tangible, that means we can measure that purpose, but the savings from them show up for downstream in production process, so that it is difficult to assign a dollar figure to them in the design phase. Uh, some of the benefits that derive from implementing CAD CAM can be directly measured. Let us see the few important benefits in CAD system. The first one is automation of routine design tasks to increase the productivity of designers and engineers. The next one is shorter lead time. It takes very less time to design a model, or we can manufacturing a component. Reduce engineering personnel requirements. Customer modifications are easier to make. Nowadays we are using parametric software. In that parametric software we need to change the parameters after completion of any sketch. So the customer modifications are easier to make. Faster response to request for quotations. Avoidance of subcontracting to meet schedules. Minimize the transcription error in drawing. Improved accuracy of design. In any modeling software, uh, it takes high precision dimensions. So improved accuracy of design. In analysis, easier recognition of component interactions, provides better functional analysis to reduce prototype testing. Nowadays, few softwares are came into market after completion of any design. We can see the how the product is manufactured in visualization mode. The next one is assistance in preparation of documentation. Designs have more standardization, better designs provided, improved productivity in tool design, better knowledge of cost provided, reduced training time for routine drafting tasks and NC part programming, fewer errors in NC part programming, provides the potential for using more existing parts and tooling, helps ensure designs are appropriate to existing manufacturing techniques, saves materials and machining time by optimization algorithms, provides operational results on the status of work in progress, makes the management of design personnel on projects more effective, assistance in inspection of complicated parts, better communication, interfaces, and greater understanding among engineers, designers, drafters, management, and different project groups. The last one is no paperworks. uh, we can share data with other applications. For example, we can model a part in CATIA. We can share that same part. We can import in ANSI software, or we can import in 3D printer for next level. Uh, now we will discussing about now we will discuss on some of the these benefits of CAD. That is the first one, productivity improvement in design. Increased productivity translates into a more competitive position for the firm because it will reduce staff requirements on a given project. This leads to lower cost in addition to improving response time on projects with tight schedules. Surveying some of the larger CAD/CAM vendors, one finds that the productivity improvement ratio for a designer or draftsman is usually given as a range, typically uh, from a low end of, that means 3 to 1, to a high end in excess of 10 to 1. This value may increase it. That means it it this value may exist from 10 is to 1 to 100. There are individual cases in which productivity has been increased by a factor of 100, but it would be inaccurate to respond that figure as typical. Let us see the uh, productivity improvement in computer design as compared to the traditional design process is dependent on the following factors. The first one is complexity of engineering drawing. Second one, level of detail required in the drawing. Degree of repetitiveness in the design parts. Degree of symmetry in the parts. Extent, extensiveness of library of commonly used entities. As each of these factors is increased, the productivity advantage of CAD will tend to increase. The next one is shorter lead time. Interactive computer-aided design is inherently faster than the traditional design process. Already we know that point. It also speeds up the task of preparing reports and lists. For example, assembly list. For we can do an assembly. First, we need to prepare individual components and save in your local disk. Then we can call from that local disk and we can do the assembly of that individual components, which normally accomplished manually. Accordingly, it is possible which a CAD system to produce a finished set of component drawings and the associated reports in a relatively short time. Shorter lead times in design translate into shorter elapsed time between receipt of a customer order and the delivery of the final product. The enhanced productivity of designers working with CAD systems will tend to reduce the repetition of design, engineering analysis, and drafting as critical time elements in the overall manufacturing lead time. The next one is design analysis. The design analysis routines available in a CAD system help to consolidate the design process into a more logical work pattern rather than having a back and forth exchange between design and analysis groups. The same person can perform the analysis while remaining at a CAD workstation. This helps to improve the concentration of designers since they are interacting with their designs in a real-time sense. Because of this analysis capability, design can be created which are closer to optimum. There is a time saving to be delivered from the computerized analysis routines both in designer time and in elapsed time. These savings results from rapid response of the design analysis and from the time no longer lost while the design points its way from the designer's drawing board to the design analysis queue and back again. Let us take one example. Uh, the success of this is drawn from the experience of the General Electric company with the T700 engine. In designing a jet engine, weight is an important design consideration. During the design of the engine, weight of each component for each design alternative must be determined. We can take uh, any component or any machine part. We need to measure. We need to take the we need to take weight as one important consideration. This had in the past been done manually by dividing each part into sample geometrical shapes to conveniently compute the volume and weights. Now it is done by computer. Through the case of CAD and its mass properties analysis function, the mass properties were obtained in 25% of the time formerly taken. Let us see the next one. Fewer design errors. Interactive CAD systems provide an intrinsic capability for avoiding design drafting and documentation errors. Data entry, transposition, and extension errors that occur quite naturally during manual data completion for preparation of a bill of materials are virtually eliminated. One key reason for such accuracy is simply that no manual handling of information is required once the initial drawing has been developed. Errors are further avoided because interactive CAD systems perform time-consuming repetitive duties such as multiple symbol placement and sorts by area and by like item at high speeds with consistent and accurate results. Still, more errors can be avoided because a CAD system with its interactive capabilities can be programmed to question input that may be inaccurate. Let's take one example. The system might question a tolerance of 0.40 in inches. It is likely that the user specified too many zeros. The success of this checking would depend on the ability of CAD system designers to determine what input is likely to be incorrect and hence what to question. The next benefit is greater accuracy in design calculation. There is also a high level dimensional control far beyond the levels of accuracy attainable manually. Mathematical accuracy is often to 14 significant decimal places. The accuracy delivered by interactive CAD system in three-dimensional curve space designs is so far beyond that provided by manual calculation methods that there is no real comparison. Computer-based accuracy pays off in many ways. Parts are labeled by the same recognizable nomenclature and number throughout all drawings. In some CAD systems, a change entered on a single item can appear throughout the entire documentation package, affecting the change on all the drawings which utilize that part. The accuracy also shows up in the form of more accurate material and cost estimates and tighter procurement scheduling. These items are especially important in such cases as long lead time material purchases. Next one is standardization of design, drafting and documentation procedures. The single database and operating system is common to all workstations in the CAD system. Consequently, the system provides a natural standard for design or drafting procedures. With interactive computer design drawings are standardized as they are drawn. There is no confusion as to proper procedures because the entire format is built into the system program. The last one is drawings are more understandable. Interactive CAD is equally adept and at creating and maintaining isometrics and oblique drawings as well as the simpler orthographics. All drawings can be generated and updated with equal ease, thus an up-to data version of any drawing type can always be made available. We can see one graph here. Horizontal axis showing different types of drawing, that is orthographic drawing, oblique drawing, isometric drawing, perspective drawing. In vertical axis showing ease of visualization. Uh, this figure shows improvement in visualization of images for various drawing types and computer graphics features. Here, in general, ease of visualization of a drawing relates directly to the projection used. Orthographic views are less comprehensible than isometrics. An isometric view is usually less understandable than a perspective view. Most actual construction drawings are line drawings. The addition of shading increases comprehension, different colors further enhance understanding. Finally, animation of the images on CRT screen allows for even greater visualization capability. The various relationships are illustrated in this figure. You can see here the one common man can easily understand when that object is in having in 3D model with animation mode. You can see here here animation is very, we can understand very easily than shading or color mode. This shading or color mode is more than solid and shading. The solids and shading more understandable than line and wireframe. Finally, a common man very easily uh, understandable animation figure than line and wireframe. The last one is improved procedures for engineering changes. Control and implementation of engineering changes is significantly improved with computer-aided design. Original drawings and reports are stored in the database of CAD system. This makes them more accessible than documents kept in a drawing vault. They can be quickly checked against new information. Since data storage is extremely compact, historical information from previous drawings can be easily retained in the system's database for easy comparison with current design or drafting needs. This is the brief discussion about various applications and benefits of CAD. Okay, again, revisit the lecture outcome. Having completed the discussion on applications and benefits of CAD, now students should be able to discuss various applications and benefits of CAD. The students are required to further information from the following textbooks. The first one is Ibrahim Jeet and Shiva Subramania RR CAD CAM Theory and Practice, second edition, New Delhi, Tata McGraw-Hill 2010. The reading chapter is 2.3.4. And another reference book is CAD CAM Computer Aided Design and Manufacturing by Jimmers Emory W. Groover, Michael P. 1984. The reading chapter is 4.5. Thank you for watching.